Let's solve Fibonacci number. This is just a function that takes an f and then you return f of n, which is the Fibonacci number of n. They give us the formula here, and these are the two base cases. F of 0 is 0, f of 1 is 1, and then to get the nth number, we just do f of n minus 1 plus f of n minus 2. This might look like recursion to you, but there's actually a faster way to solve this. These are the companies that ask this question. And I do think this is probably an important one to memorize, or at least know how to do. If you're in an interview and you just explained your 500 different startups and 20 AI projects, and then they ask you to code Fibonacci number efficiently, then you're kind of cooked. So this is the normal way, right? You make a recursive function, takes an n, and then you get the base cases. So if n is less than or equal to 1, then you return n. Otherwise, you just return Fibonacci of n minus 1 plus Fibonacci of n minus 2. And then you do Fibonacci. And then you return Fibonacci of n. And that works. It looks like it works, but if you submit it, then you can see it's not very efficient. In fact, this is like extremely inefficient. It's actually O of 2 to the n, and they don't actually give you enough test cases that you realize that this would probably never work with numbers that are decently large. So I'll tell you a way that you can do this in O of n time and constant space as well. So we don't actually need recursion. We just need three variables here, which is f of n minus 1, and f of n minus 2. So let's make that. I'm going to put f of n as 0, f of n minus 1 is 1, and f of n minus 2 is 2. We're going to assume that we start f of n at the second Fibonacci number, because f of n minus 1 would be 1, which is given to us, and f of n minus 2 would be 0, which is given to us. So the base case here would be just to return n if n is less than or equal to 1. Otherwise, we will iterate like this. For empty iterator, because we're not using this variable, in range, and we want to start from the second Fibonacci number because we already know the 0th and first one, and we have to because we defined them as so back here. So we start from the second one, and we have to go to n plus 1 in order to get the nth Fibonacci number, because that's how range works. It stops before n. Now we look back at the formula and see f of n equals f of n minus 1 plus f of n minus 2. And then after this, we want to update f of n minus 1 and f of n minus 2 to their new respective counterparts. So f of n minus 2 is going to equal f of n minus 1, and f of n minus 1 is going to equal f of n. So that prepares us for the next calculation. And at the end here, we're just going to return f of n. As you can see, it's much faster. This might be a bit confusing at first because of the variable reassignments, but if you stare at it long enough, you'll probably be able to get it. Worst case, you can just kind of pseudo-memorize this if you really need to. There's actually an even faster way to do this in O of log n and O of 1 space, but it involves an equation that an equation that probably not many people would know. But at this point, it's basically just plugging things into an equation. And I don't really know if your interviewer would want that or if they would be impressed with it. So I would just stick with the actual logical solution instead.